Good day, everyone. Today we will be discussing about calculating appropriate sample size. So last meeting we discussed about confidence interval estimation for population proportion, and on week 6 we discussed about confidence interval estimation for population mean. So now how about if we are asked about the appropriate sample size given the margin of error? So here are the formula that we will be using on today's discussion. First, calculate the appropriate sample size of a population mean, you need to use this formula. N is equal to Z sub alpha over 2 times sigma all over E squared. And then to calculate the appropriate sample size of a population proportion, you need to use this formula. N is equal to P hat times Q hat times the quantity C sub alpha over 2 all over E quantity squared. Let's try a problem. Okay, Maria wants to study the eating habits of Mangyan tribe. She wants to estimate the population mean within an error of 0.02 of its true value and standard deviation of 0.3. Find the sample size that she needs when the confidence level is 90% and 95%. Draw your conclusion based on the result of your answer. So the first thing that we're going to do, we're going to identify the problem if the problem deals on population mean or population proportion. As you can see, it is on the problem. We're dealing with population mean. So since we're dealing with population mean, before we proceed on the applying the formula, we're going to identify first the confidence level. As you can see, the confidence level is 90% and 95%. So if the confidence level is 90%, we already know that the level of significance is 0.10 for 90% and 0.05 for 95%. Now, to find the z-value, we're going to take a look on our t-distribution table. So, z-value for 0.10 is 1.645, and for 0.05, we have 1.96. We also have the given for standard deviation, which is 0.3, and margin of error, which is equal to 0.02. Now, let's start with the solving the confidence level is 90%. So by applying the formula, we're going to substitute the given values to the given formula. So instead of writing z, we're going to write 1.645. Instead of writing sigma, we're going to write 0.3. And instead of writing e, we're going to write 0.02. Now to solve this one, we're going to press 1.645 times 0.3. So we have double parentheses, close parentheses, divided by 0.02, close parentheses, press squared, so that you can now get the final answer. Again, to find the final answer, press on your calculator, open parentheses, 1.645 times 0.3, close, divided by 0.02, close, and then press squared, you can get 608.86. However, the final answer is 609. Why? Because we're dealing with population, and we already know that we're dealing with discrete variable. Since we're dealing with discrete variable, it is not allowed that we're going to have decimal places. So therefore, 608, we're going to round up. It means that we're going to add 1 on the whole number. It will be 609. Let's try another example. Or for 95%, for 95%, instead of writing z, we're going to write 1.96 times 0.3 all over 0.02. Now, in order for us to find the final answer, again, you're going to do double parentheses 1.96 times 0.3, close, divided by 0.02, close, then press squared. You're going to get 864.36. Or approximately, the final answer is 865 because we need to round up 864.36. Now, for our conclusion, we're going to say that based on the results of the answer, when the confidence level increases, the appropriate sample size also increases. So, if as you can see, this is the confidence level, it increases, while as you can see on the appropriate sample size, it also increases. So therefore, that is your basis for your conclusion. Let's try another example. A bottle of fruit juice drink is claimed to be 500 ml, standard deviation of 20 ml. Joshua wants to investigate the same fruit juice drink to estimate for the true population mean content correct to within a 5 ml and 10 ml, adopting 95% confidence level. How many bottles of the fruit juice drink of the same brand does he need for the sample? First, identify if the problem deals on population mean or population proportion. So as you can see, we're dealing with population mean. So therefore, we have population mean. Now let's identify the confidence level. So as you can see, the confidence level is 95%. Now, since we're dealing with 95%, we already know that the level of significance is 0.05. Now, as you can see on the distribution table under Z, C under 0.05 is equal to 1.96. Now, we already know that the standard deviation is 20 ml, and our margin of error we have 5 ml and 10 ml. Now, let's start with 5 ml. So to find the appropriate sample size, again, we're going to use the same formula. N is equal to Z sub alpha over 2 times sigma all over E. By substitution property, it will be 1.96 times 20 all over 5. So to solve this one, again, you're going to do or press this in your calculator, double parentheses, 1.96 times 20, close, divided by 5, close parentheses, press the squared bot, and then you're going to have the final answer, which is 61.47, or approximately that is 62, because we need to do round up. Let's proceed with 10 ml. For 10 ml, we will be having N is equal to 1.96 times 20 all over 10. So again, press the calculator in your calculator, double parentheses, 1.96 times 20, then close, divided by 10, close, then press the squared button, and then we will be having equals, so it will be 15.37, or approximately that is equal to 16. So as you notice, as the margin of error increases, the appropriate sample size decreases. So therefore, we can say that based on the results of the answer, when the margin of error increases, the appropriate sample size decreases. Let's try another example. The mayor of a town wants to use the proportion of a population to determine the sample size needed to interview regarding plans about a new market building. He wants to be able to assert with a confidence level of 99%. Survey in the past has shown 65% approval. How large a sample does the mayor need if the margin of error will be 0.02 and 0.05? So let's start with identify the problem deals on population mean or population proportion. As you can see, we're dealing with population proportion. Now, since we're dealing with population proportion, before applying the formula for sample size pertaining for population proportion, we need to identify the confidence level. So as we can see, the confidence level is 99%. Since it is 99%, we already know that the level of significance is 0.01. Now, taking a look on your t-distribution table, on the bottom part, we can see Z. So therefore, Z under 0.01, that's equal to 2.576. Now, in this one, we don't have mean and standard deviation. However, we have P hat and Q hat. So for P hat, we deal on 65% because this is the survey in the past that's shown 65% approval. So if P hat is equal to 65% or 0.65, we already know that Q hat is 0.35. How did we get that? We have the formula 1 minus P hat. So 1 minus 0.65, we already have 0.35. Now, to find the margin of error here is 0.02 and 0.05. Now, let's start with 0.02. So, for 0.02, let's start with applying the formula P hat times Q hat all over C sub alpha over 2 over E, or times C sub alpha over 2 over E, quantity squared. So, by substitution property, instead of P hat, we're going to write 0.65. Instead of writing Q hat, we're going to write 0.35. This is the P hat and the Q hat. Instead of writing Z sub alpha over 2, this is Z sub alpha over 2, we're going to write 2.576. Instead of writing E, we're going to write 0.02. Now, how are we going to solve this in your scientific calculator? So, just only press 0.65 times 0.35 times parenthesis 2.576 divided by 0.02 quantity squared, and then press equal, you will be able to have the answer 3,774.10, or approximately it is equal to 3,775. Now, how about for 0.05? For 0.05, we're going to use the same formula. By substitution property, it will be 0.65 times 0.35 quantity 2.576 all over E quantity squared. So by pressing this on your calculator, it will be 0.65 times 0.35 times the parenthesis 2.576 divided by 0.05 quantity squared, and then press equal, you will be able to have 603.86, or approximately that is equal to 604. Now, for your conclusion, take a look. The margin of error increases. So if it increases, you can see that the appropriate sample size decreases. So therefore, our conclusion will be, based on the results of the answer, when the margin of error increases, the appropriate sample size decreases. So that's all. Thank you and God bless everyone. Don't forget to hit the like button and subscribe on our YouTube channel so that you will be updated with our video tutorial. Thank you and God bless.